Hello everybody, welcome to Forces Unit 1, Lesson 6. This lesson is about springs and extension. You are going to need something to write with, that's a pen or a pencil, something to write on, a piece of paper or a book if you've been using that. You're going to need a ruler or a straight edge because you've got a little table to draw a little bit later on, and you can use a calculator if you want to as well. If you don't have these things, pause the video and then press play when you've got everything you need ready. Okay, let's start off as we always do with a little mini test from last lesson. Answer the questions on your piece of paper or in your book, pause the video and we'll go over the answers when you're ready. Let's see how you got on then. Mass is essentially the sum total of all the particles within an object. That stays the same, so mass always stays the same. Gravitational field strength is how big the pull of gravity is in a particular place. The equation for weight is mass times gravitational field strength. Work, force times distance. What do we mean by balanced forces? Well, it's when the forces pulling one way are the same as the forces pulling the other way. Or you could have said the resultant force is zero. What happens to an object if the forces on it are balanced? Well, if the forces are balanced, there is no change in speed, no change in direction. Got all those right? Well done. On to some new key ideas for today then. The first idea I want to introduce you to is the idea of extension. Imagine you've got a house. That house is 10 meters long. You decide, actually, I could do with a bit more space. So you build an extension on the back. Now, the new length of the house is 15 meters. What you can say is the extension is how much longer it is compared to the original length. So it's now 15, it was 10, so the extension is 5 meters. That's a very simple idea. But what happens if you decide, actually, I do like the extension, but we could do with a little conservatory on the back for the summer as well. So there's our little conservatory. Now, the new length of the house is now 21 meters. Now, this is the bit that people often get wrong. The extension is this bit here, how long it is compared to the original length of the house. Now, the original length was 10. We built a bit of an extension, we built another bit. The extension now is the 21 take away the 10, so the extension is now 11. It is not this extra bit here, it's all of it compared to the original length. Let's see how that applies to springs. So here's a spring. The original length of the spring, this would have no load, no weight on it at all. We're going to measure from the springy curly bit here. So we're going to measure from there to there, and let's say it's 5 centimeters long. Now that spring, no weight on it, so it's still its original length. So we can say at the moment there is no extension, still how long it is when it started. We add some weight on it, the spring will get a little bit longer. Let's do a slightly longer spring there. Now, if we do some measurements, we're going to measure to here, same point here. The length is now 7 centimeters. The extension is now 2 centimeters. It's that extra bit here. It's compared to the original length. If we put even more weight on it, so the spring gets even longer, we're now measuring to this bit here. If the new length is 9 centimeters, the extension is how long it is compared to the original length on this line here. The extension is now 4 centimeters. It's new length compared to the length it started with nothing added to it. Okay, we're going to do a little experiment now, or I'm going to do a little experiment. So I need you to copy down onto your piece of paper, into your book, whatever, this table. Don't forget to use a ruler. Don't forget to include the units at the top of your table. Pause the video. Okay, do a little experiment now. This is the experiment we're going to do, or experiment that I did a few days back. It consists of a spring, and we're going to add various different weights to that spring and see how the the weight that's added affects the length of the spring. Now, if I zoom in a little bit, you can see I've put a splint at the top and the bottom of the spring, and those there just so I can compare it to the ruler very, very easily and take some very clear readings. So let's get going with our experiment then. I'm going to add various little weights to provide some force for my spring, and we're going to see how long it is on each occasion. So first little one. So we're going to start it first of all with the spring with no weight added at all. And you can see there on the ruler that's coming out as 2 centimeters. Let's bring the camera down a little bit. There we go. 2 centimeters is the length with no force added. So we're going to try it now. This time we're going to add 0.1 newtons. We're going to add that hanger to the video and see what that comes out as. So the hanger has a weight of 0.1 newtons. Put it on. Should get a little bit longer. Let's have a little look. That is coming out as slightly longer, 2.1 centimeters. 2.1 centimeters. So add that to your table. And let's have a look when we add one of these slotted masses on, which brings our force up to 0.2 newtons. There we go, and that looks like it's coming out as 2.4. So 2.4, write that in your table. Let's look at the next one. We're going to add a second slotted mass on, so we've now got the 0.1 of the hanger, and we've got 2 masses, so it's 0.3 is the force, and that is coming out as 2.9. So write 2.9 into your table. Let's add another one on. So we're now going with 0.4 newtons. Let's have a little look. That is coming out as, I reckon, 3.2 for that. So let's add 3.2 into our table. And let's do the next one. So we're now adding an extra 0.1 newtons. So we're now up to 0.5 newtons. Let's see what that's done for our spring. Ooh, nice and close. Yeah, and that's 3.6. 3.6 centimeters, that one. Let's go to the next one. Add 3.6 into the table. We're now adding an extra slotted mass. So this is taking us up to 0.6 newtons. And I reckon that's 4.0 is the length. So add 4.0 to the table. And now we're going with 0.7 newtons. So extra 0.1 added. And this is coming out as 4.2, I think. 4.2. So put 4.2 in the table. Let's have a look now at 0.8 newtons, see what that comes out as. So we add an extra 0.1 newton to our force, and that is coming out 4.6, that one. So add 4.6 to your table. Now we're doing 0.9 newtons. That looks to me like 5.0. So add 5.0 into your table. And now we're going to have a look at 1 newton. So this is the base, which is 0.1 plus 9 little masses, 1 newton. Let's see what that comes out as. So there's our final 0.1 newton going on. That comes out as 5.4. So add that into your table. The next step then is to calculate the extension. Now you should remember extension is the length it is with all the extra force added, take away the length it was when nothing was added. So this one, 2, take away 2, because obviously it's got no force on it, is 0. And then 2.1 take away 2 is 0.1. 2.4 take away 2 is 0.4. 2.9 take away 2 is 0.9. And so on. And that's how we get all of these results here. the last one, 5.4 take away 2 is 3.4. So you need to write in your table all of these extensions. Pause the video and then we'll move on to the next bit. Okay, if you've got those results written down, then we'll move on to the next bit. I've got a few questions about the method that we used here. So have a look at these questions, write down your answers. If you're not sure about what the answer should be, have a little guess, it doesn't matter. Pause the video and I'll go over the answers in a moment. Okay, so why did we fix a wooden splint to the top and bottom of the spring? Well, quite simply, we did that so it's always measuring from the same point at the top and the bottom of the spring, always measuring from the same points. Why did we clamp the ruler? Easy, to remove any wobbling when taking measurements, and also so we can get the angle of the measurement at right angle, so we didn't sort of sometimes have the ruler going sort of diagonal across, which would give us the wrong readings. Why did we use a ruler that went up in millimeters rather than centimeters? Well, the reason for this is the changes were smaller than 1 centimeter. If we used a centimeter scale, some of the changes would not have showed up as changes. They would have had the same reading as before. For example, 2.4 would have rounded to 2, 2.1 would have rounded to 2. So those two readings, although they were different, they would have had the same value in our table. We wouldn't have been able to see the changes. To finish this lesson off then, we've got a little mini test for you. See how you get on, pause the video and I'll go through the answers in a moment. Okay, let's see what you should have done, see how you got on. So, elastic band is 20 centimeters long, it is stretched to 35. How much is the extension? So it's the final length, 35. Take away the original length, which is 20. That comes out as 15 centimeters. A boy does a bungee jump. The bungee rope is 20 meters long when it is not stretched. At the bottom of the jump, the bungee rope is 45 meters long. What's the extension of the bungee rope? Very simple. 45, which is the stretch length, take away the unstretched length, which was 20, is 25 meters. Two students are adding masses to a spring. With no masses added, the spring is 5 centimeters long. Remember that 5 centimeters because you've got to take that away from everything. When Robbie adds masses to the spring, it's 8 centimeters long. When Gary adds some extra masses to the spring, it is 12 centimeters long. What is the extension of the spring after each student? So when Robbie adds masses to the spring, it's 8 centimeters long. So his is going to be 8 take away 5. And then when Gary adds masses to the spring, it's going to be 12 take away 5. Biggest mistake people make here is they say, well, when Gary added it, it was 8 before Gary added, so 12 take away 8 is 4. No, it doesn't work that way. It has to be compared to the absolute original length when nothing is added. You got those right, well done. Anything you're not sure of, feel free to rewind the video and have another look. Otherwise, that's it for today. Thank you very much. That's all, folks.